Hello, dear friends. I'm Professor M. Masoom Raza, Department of Library Information Science, AMU here. Dear friends, in the previous lecture, I told you about the system analysis and design. I told you what a system is. I told you the characteristics of a system, components of a system, and I even told you how a library can be a system. And all the components of the libraries, they were broken down just to make you understand what are the components or what are the characteristics of a system, library system. And I also told you about the advantages and disadvantages of a system. System, definitely they have advantages, and along with the disadvantages, if they have the disadvantages also. If it is poorly, you can say, designed and finally implemented on any organization, and ultimately if it is not successful, so it leads to a lot of losses, a lot of chaos. So one has to be very careful that when you are trying to get it redesigned after proper analysis, and when you are trying to get the system redesigned, try to uh, examine it first, train your staff, then implement it, and then try to see that things are working properly. Try to have the proper feedback and try to monitor the staff also, how they are learning, with what pace they are learning. And slowly, gradually, the new system will pick up. But even you should be prepared for any kind of, um, you can say, the means any kind of drawback. And if the system is not able to work properly, then definitely you should have a backup, or you should have a alternative, so that immediately you can manage the essential services in your organization or in your system, or maybe in your library. So so in this lecture, I'll be telling you about the development cycle. Every system has got a life cycle. As a human also, you can see, if I give you example of a human being, we have so many systems working, and all these systems are working in they are interconnected and interrelated, and they are working in consonance. You just imagine your circulatory system, your reproductive system, your muscular system, all your system. If you just imagine how many systems are working in your body, and they all are working tirelessly. Heart is not taking any rest. You can see the lungs constantly 24 by 7 it is working. Heart is working, lungs is working, kidney is working, and your liver is working, muscles are working. So where's the time? Means all these systems are working in coordination. And probably this is the best example that human being is made up of so many systems. And do you think if any system collapses, it leads to a disease? And when one system collapses, slowly, gradually, we'll see all the systems, because it's a question of supply and process. If the supply is interrupted, or if the process is interrupted, it leads to the spoiling of one system spoils the other spoils the third spoils the fourth. This is how the whole body collapses. And ultimately, when all the system collapses, it is your natural death. So, but in case of a mechanical system, when we talk about the mechanical systems, the system in which we are running a particular organization, so we have to see to it that every system has got a life cycle. And by when they complete the life cycle, they will start non-performance, inefficiencies, inaccuracies. So just just to correlate with the human, just see with the passage of time, when we are progressing, age is progressing, slowly, gradually, you find a lot of problems are there. You're not able to walk properly, or sometimes you're not able to breathe properly, sometimes you're not able to do your daily odd jobs. So the same thing works with the system also. Every system has got a life, and after life, what you will feel, it starts giving you inaccuracies, inadequacies. So a lot of footfalls will be there, a lot of loopholes will be there. And when you find that it is not efficient, it is not giving you proper output, and it's leading to inaccuracies, so means the system needs a change. And when you feel that system needs a change, you have to strategically go for the analysis. Just when you go for the analysis, you have to go for a comprehensive analysis of all the workflows, all the processes, all the tools, all the techniques, and then try to, after analysis only, then you go for a new design. And when you go for a new design, slowly, gradually, it will take time. People will adopt and adapt. And once the people adopt and adapt, your system, your organization once again becomes smooth. For at least, you know that every system has got a certain life cycle. So for a time, at least maybe for a decade or so, you can be relaxed. But definitely, the versions and updates that you have to keep on changing, keep on adding new things, those things will be there. Because if you don't upgrade, don't change anything, don't add any component, definitely your progress will not be up to the mark. So you have to keep on doing that to remain competitive, to remain progressive. You have to be um, capable of adapting to any kind of changes. So within this lecture, I'll be covering the system development cycle, life cycle, where we will cover the system planning. These are the processes of the system. First, we should go for the planning and selection. Then we'll go for the analysis. Then third is we'll go for the system designing. Then we have the system implementation and operation. And then again, there should be, after implementation, there should be feedback mechanism. And once the feedback, after feedback, you can, there is a possibility that you can improvise the system existing, whatever new system you have adopted or implemented, that system can be improved further, and then it can be re-implemented. That is also possible. So just try to understand what is a system life cycle here. So when I say system development life cycle, that is SDLC, basically is a structured approach used to plan, design, implement, and manage the development of information systems or software's application. It provides a framework for organizations to ensure that new systems or applications meet their needs effectively and efficiently. So, phase one. Phase one, you can see two things are there. One is identification of need, and second is feasibility study and scope definition. So, we'll take one by one. Identification of need. The library identifies the need for the new or improved system to manage its operations more efficiently. This could arise from challenges in existing procedures, the desire to offer additional services, or opportunities to enhance user experience through technology. And second important thing in this phase one is feasibility study and scope definition. So the library conducts a feasibility study to assess the economic, technical, and organizational feasibility of implementing the proposed system. This study helps determine whether investing in the new system is justified and feasible. Additionally, the scope of the proposed system is defined, outlining the objectives, functionalities, and boundaries of the system. The detailed project plan is developed, specifying the resources and timeline required for system development and implementation. So during this phase, the library evaluates the costs and benefits of implementing the new system. The feasibility study considers factors such as budget constraints, technological compatibility, and organizational readiness. How much the organization is prepared to accept it. Once the feasibility study is completed and the scope of the project is defined, a formal proposal is presented to the library management for approval to proceed with the subsequent phases of system development life cycle. Then you can see the phase 2 starts, and the phase 2, what are the process here is, you should study the current library procedures first, then determine the system requirements, then structuring requirements, then generating alternative designs, then you can have the comparing the alternatives, and then only you can go for the output. So what basically it includes, this first step especially, where the system current library procedure has to be studied here. Basically, it requires that the analyst conducts a comprehensive review of the library's existing procedures and the information systems used for various tasks, such as cataloging, circulation, acquisition, and pattern management. And this entails gaining insight into how these systems operate and identifying their strengths and weaknesses. And in the next step, determining the system requirements. Here, what is to be done is the initial subphase of analysis involves collaborating with the library staff and patrons to determine the requirements of the proposed system. This includes gathering input to understand their needs and expectations from the new system. The analyst meticulously examines the existing system, whether manual or computerized, that may undergo replacement or enhancement as part of the project. In the third step, you have to structure the requirements. Following the collection of the requirements, the analyst organizes them based on their interrelationships and eliminates any redundancies. If anything is superfluous, that has to be removed. So, this process entails prioritizing and structuring the requirements to ensure they are clear and actionable. And then in the next step, you have to generate the alternatives. So, the analyst will create various initial designs that align with the identified requirements, and these designs may offer different approaches or the solutions to address the library's need effectively, such as improving cataloging efficiency or enhancing pattern service. And in the next step, you have to compare those alternatives. Whatever alternatives have been designed, in the next step, you will be comparing those alternatives. So, these alternatives design generated are then compared to determine the one that is best fulfills the requirement. Out of 3 or 4, whatever the design has been generated, you can compare which one is the best one in terms of efficiency. So, when you compare it, there are so many parameters, so many yardsticks are there. And what are those constraints? It can be cost, labor, and technical feasibility. And this comparative analysis aids in identifying the most suitable solution for the library. And then the last is output. So, the culmination of the analysis phase is the description of the recommended alternative. Means only one system which has been recommended, that is to be taken. So, recommended alternative solution proposed by the analysis team. This recommendation is founded on a comprehensive assessment of the library's requirement and constraints, aiming to enhance library services and operations. This is a phase 2. So, at least here you can you have a chance to study the existing system, determine the system requirements, structuring all those requirements, and then when try to have the alternatives. And while determining the system requirements, you can talk to the people, patron, and you can talk to the staff, and what the staff require, what the people require, or what the students require, or what the research scholars require. All those things can be gathered, and then it can be structured, and then you can have multiple designs. You can have at least 2, 3, 4 designs, and then we can look for, on the basis of the various parameters, you can look for the best one, which is efficient also, cost efficient also, it is beneficial, cost beneficial also, and that is to be finalized. Out of so many designs, the design which your authority or your library management people have selected, that is considered as a real output. Till phase 2, we have the output, we have decided the design now. So, in the phase 3, then the designing starts. So, when you have to design the system, you have these steps: logical design, physical design, decision making, and technological acquisition, then output. So, especially in third phase, which is known as system design, is particularly relevant in the context of library operations. This phase involves the transformation of the proposed solutions identified during system analysis into both logical and physical system specifications tailored to the unique needs of the library environment. Here is an in-depth look at the task involved in this phase. Means The design should be logical. Within the logical design, analyst crafts specifications that are not tied to any specific hardware or software platforms. Instead, the focus lies on designing this system based on libraries, operational aspects, and functional requirements. This includes the design of interfaces, databases structure, search functionalities, circulation processes, and user management system. The logical design aims to understand how the system will impact various library functions and services. Then second aspect of this phase 3 is physical design. So transition to the physical design stage, the logical specifications are translated into tangible or technical specifications that are intricately linked to specific hardware and software platforms. This involves converting conceptual designs into structured system blueprints that can be implemented using programming languages and existing library infrastructure. An analyst will carefully design various components such as the library catalog system, pattern management system, circulation desk interfaces, and online resource access points. The key decisions are made regarding programming, language, database systems, hardware configurations, and networking architectures, ensuring seamless integration with existing library systems. Third step in the phase 3 is decision making. So, throughout the physical design phase, the analyst team engages in critical decision making processes concerning technology choices, system architecture, and integration strategies. These decisions play a crucial role in finalizing the hardware and software plans initiated during the analysis phase, ensuring alignment with the library's goals and objectives. So, considerations may include selecting library management software, integrating RFID technology for inventory management, or implementing cloud based solutions for digital collections. Next step in phase 3 is technology acquisition. Once the physical system specifications are finalized, any new technology required for the system implementation is acquired. This may involve procuring hardware components such as servers, workstations, RFID scanners, and network equipment, as well as software licenses for library management systems, cataloging softwares, and digital repository platforms. The goal is to ensure that the selected technology solutions seamlessly support the library's operation and enhance user experience. And the last step is output. So, the culmination of the design phase results in the production of detailed physical system specifications documented in the form of technical diagram, software requirements specification, and implementation plans. These specifications serves as a roadmap for system development and implementation, guiding programmers and IT professionals in constructing the envisioned library system. Additionally, the documentation facilitates communication between stakeholders, ensuring that the final system aligns with the library's vision and objectives. Then the next is system implementation and operation. So this is phase 4, and the first thing here is implementation. So system implementation basically encompasses several steps, including coding, testing, and installation. During coding, programmers develop the software components of the system based on the physical system specification outlined in the previous phase. Subsequently, rigorous testing is conducted by the programmers and the analyst to identify and rectify any error or bug, ensuring that the system meets the specified requirements. Finally, the system is installed on the existing or the new hardware, and users are introduced to it through training sessions. Second step is planning. The planning for testing and installation should commence early in the project planning and selection phase. Both testing and installation necessitate comprehensive analysis to devise an appropriate approach. Planning ensures that sufficient resources, such as time and staff, are allocated to testing and installation activities, thereby facilitating the smooth execution of these processes. And the third step is user support. So, system implementation activities also include providing initial user support. This may entail finalizing documentation, developing training materials, and offering ongoing user assistance. Documentation aid users in understanding how to effectively utilize the new system, while training programs equip users with the requisite skills for operating it proficiently. Ongoing users support may involve help desk assistance or additional training sessions aimed at addressing any queries or concerns arising during system usage. Several system concepts aids system analysis in effectively analyzing and designing the system. They are decomposition. This basically involves breaking down a system into smaller components or subsystems. This process results in smaller, more manageable pieces that are easier to understand and modify independently. Then we have modularity. Modularity is a direct result of decomposition and refers to dividing a system into chunks or modules. Modules represent the system, simply making it easier to understand, redesign, and rebuild. Then we have coupling. Coupling refers to the degree of interdependence between the subsystems within a system. Then we have cohesion. So, cohesion measures the extent to which a subsystem performs a single function of the task. Highly cohesive subsystem focuses on performing a specific function effectively, leading to better organization and maintainability of the system. In contrast, low cohesion may result in subsystems that perform multiple unrelated functions, making the system more complex and harder to understand. So, with this, friends, I hope you have understood system analysis and design. So, we have covered so far what a system is, what are the components of a system, what are the characteristics of a system, and how a library can be considered as a proper system, how system is analyzed, how it is designed, and how it is implemented. And we have also understood what is the life cycle of a system. So, we have seen all the four phases where one has to study the existing system, then we have to collect the data related to the need of the present requirement or need of the system, and accordingly the analyst will come up with the designs, and any one particular design is chosen as the best by the management or by the authorities, and whatever has been selected as a right alternative, the system design process initiates. After designing, taking into account all the specifications, and then finally it has to be implemented, and then only we can collect the feedback both from the patrons as well as the staff. If the staff and patron they recommend something, maybe some sort of changes, those can be again it can be added in the new system, and then again it can be implemented to see that things work normally and people accept it readily. And if the staff and the patron they accept it readily, means it is a win-win situation, and the library system starts giving you optimum output, optimum efficiency, and because it is a young system, so-called young system, the old system has died now and the young system has replaced it. So the young system will live its own life, and probably this system will also meet the same fate by the maybe within a decade or maybe 2 decades, when the new technology or new things come up or new things are in the market. So definitely the older system has to leave the place, and the new system will be replacing it. So whenever you feel the need, your library feels a need or your organization feels a need, they have to go for a thorough analysis, thorough feasibility studies, and even the requirements of the users, requirements of the staff, and then only system has to be designed, modified, updated, and so that it can live its life. So with this we have finished this area, and in the next lecture we will take up some new area. Thank you very much.